Hi, my dear friends, hoping that you are all fine. And right now, in the second half of this October-November 2020, paper 6, variant 1, we are starting the questions linked with the physics of waves and in the end, some electricity and magnetism question. So let's start with question number 3 of October-November 2020, paper 6, variant 1. This is the alternative to practical exam basically. And we are talking about now, see, a student investigates the magnification of the image produced by a lens. Magnification mean by how many times the image is bigger than the object or it is smaller than the object. Magnification in general, most of the times, it is the ratio of the image size to the object size. And it is one of the physical quantities which is having no unit because it is a ratio between the two similar quantities like length over length. So if the length is measured in centimeters, the other one will also be measured in centimeters. So centimeter over centimeter, it will be cancelled out. I will be discussing with you people in the next part of the question. Now, figure shows the apparatus used, and always the apparatus is arranged in the same fashion. On extreme left, there will be the illuminated object. Lamp is there, object is in between the gap over here. Then the lens, which is on a bench, and the screen, which is also supported by a bench to keep it vertical. And screen is the place actually where image is made. Image of the object is made. Now here are some important factors, and always the arrangement is on extreme right. There is screen where the image is made, and on extreme left there is an illuminated object, and in between object and screen there will be the lens. And it will not be just place the lens in between. There will be a particular arrangement, particular space or distance from the object to the lens and also from the lens to the screen. These will be the distances where the image on the screen is not blurred. It is very clear, a distinct image, a focused image is formed, and then we are measuring this U and V, and we are finalizing the position of the lens or finalizing the position of the screen. Figure 3.2 shows a triangular hole. See figure 3.2, and this is figure 3.2. In a card that forms the illuminated object, figure 3.2 is drawn actual size. So whatever is the length of HO is given, that is the actual length. So illuminated object is there, and what we are supposed to do on figure 3.2, measure and record the height HO of the object. So we are supposed to make use of the ruler to measure this length, and this is coming to be, and this length can be in centimeters, it can be in millimeters. And how we are getting this idea that it is in millimeters or it is in centimeters? Just by reading the theory given in different places. Like here, U values are given in centimeter, the values for U are given in centimeters. And similarly, if we will move down, you can check when he's repeating this experiment to plot a graph. So the other values are also given in what? They are all in centimeters. So it means we need to take this height also in centimeters. So when we are placing the ruler and trying to measure it, it is almost, my dear friends, mean which height? Arrowhead length. This one. It is 1.5 centimeters. And don't forget to write the unit. If you are writing only 1.5, this value is numerically correct, but you are not writing the correct unit, you will get 0. The mark awarded to you will be 0. So correct numerical value along with correct unit is needed here. Then the student places the lens a distance U equal to 20 centimeter from the illuminated object as it is shown here in the beginning. U in the beginning is 20 centimeters. He moves the screen slowly until a clearly focused image is formed on the screen. He measures, and when the image is formed on the screen, it means it is a real image. And real image property is, the definition is the image which can be formed on the screen. He measures the distance v between the center of the lens and the screen. And another very important thing to get the accurate results, see the distance. Either the distance is u or the distance is v. Either the distance u or the distance v, they are all taken from the center of the lens. They are taken from where? Not from the sides of the lens. No, they are taken from the center of the lens. So to get the more accurate measurements for the focal length, for u and v, ultimately u and v first, and then ultimately focal length, we need to take all the measurements from the center of the lens. This is one of the very important improvements in this case. Then he repeats the procedure using the values of u equal to 25. He is increasing the distance between the object and the image in regular intervals, not randomly. So 25 centimeters, then plus 5 30 centimeter, plus 5 35 centimeter, and again plus 5 40 centimeters. The readings are shown in the table. Calculate. The readings are shown in the table 3.1, and we are supposed to calculate and record in the table the magnification m for each value of u. Use the equation m is equal to v over u. Now m is, see, u is given in centimeters, v is given in centimeters. No unit is there for magnification. The reason for that, m is equal to u over v, sorry, v over u. So 70.9 over 20.0. This is in centimeters, this is also in centimeters. So centimeter is cancelled with centimeter. There is no unit remaining. So when we are doing it, we are getting the answer for values of m. So this one is 1.55, sorry, not 1.55, 3.55 or 1.55. So here I'm writing 3.55. Then as we will divide 41.5 over 25, we are getting, I'm rounding it off, and we are getting 1.66. Then 32.5 over 30, we are getting 1.08. Then the next value is 28.1 over 35, so it will be less than 1, and it is almost 0.80. And finally 25.6 divided by 40, and we are getting 0.64. Now magnification, it is the ratio between the two same quantities, mean both are lengths, so that's why units are cancelled out and no unit is there. Now the next, as usual, now again we are told to draw a graph, to plot a graph of u in centimeters on y-axis. So never forget to label the axis before starting the graph making, plotting the graph. So u in centimeters on y-axis, and magnification without any unit on x-axis. And but it is clearly mentioned that start the y-axis at u is equal to 20. So u is equal to 20. Now we have to go from 20 to 40. So if I'm going 20, 30, 40, if I'm writing like here 20, 30, 40, so it will be, the data of u will not be scattered on half of the grid on y-axis, at least half of the grid, and I'm always preferring to spread it, that it is spreading on more than half of the grid on y-axis as well as on x-axis. So for u, what we are making, see here, this is 25.0, this one number is 30.0, this one is 35.0, and here this is 40.0. So see, only one box is left out of 5 big squares. 4 squares are occupied with data. So correct. Now m, let's see what are the values of m. They are from, see, maximum value is 3.55, it is more than 3.5, and minimum value is 0.64, it is more than 0.5. So if I'm going, see, if I'm making it 0, 1, 2, 3 and 4, still it will not be that much workable. So what I'm going to do here, let's put this starting from 0. Here this is 0.5, I'm writing this one 1.0, 0.5 I'm adding with every square. So here 1.5, this one 2.0, now here 2.5, this value is 3.0, here 3.5, and we need to go till 3.55, so 4.0. So on y-axis and x-axis, the data of magnification is scattered over whole grid, in one more than half of the grid, so that is perfect. Now let's start locating the points. When u is 20 centimeter, 3.55, but before moving forward, see, we must know the idea about the least count, or what is represented by one small square. One small square. So the rule is one small square is equal to, I'm writing 1 SS, one small square. So the difference between two consecutively marked values, 0.5 minus 0 over 10. So each small square is 0.05. So when u is 20, the value of m is 3.55. See, this is 3.50, this point is 3.55. Now next is when the value has become 25, 1.66 is the magnification, 25 here and 1.66, see, 25, this is 1.5, this is 1.6, so two boxes equal to 0.1 here. So 1.6, this is 1.65, so little bit after this, so this is 1.65, 1.66, sorry, so it should be exactly here. Then my dear friends, when the value of u has become 30, the value of m is 1.01, 30 and 1.08, sorry, 30, this is 1, this is 1.5, no, 1.08. So see, this is 1, this is 1.05, this is 1.1, so it is little bit ahead of it, like here, a little bit ahead of 1.1. Then next value is 35 and 0.80. See, 35, this is 0.5, 0.6, 0.7, and this is 0.8. And the last value at 40, it is 0.64. 40, this is 0.5, this is 0.6, this is 0.65, so just ahead of it. So these are the values marked. So up to the moment we have scored 3 marks. How the 3 marks? First mark is awarded to the student when he is labeling the axis correctly, like the value of u in centimeter should be on y-axis. That is done. Already we have done this. Then the second is m, magnification on x-axis. That is also done. Second mark is awarded to the student when he is choosing the scale in such a way more than half of the grid is covered with data on y-axis and also on x-axis. That is also fulfilled. Third mark is awarded to the student in general when he is locating the points with cross sign, with plus sign, like I have used the cross sign. You can also use the plus sign, but if you are using dot, so you are not only using the dot, you have to write the dot in a circle, then it will be accepted. And the fourth mark will be the line of the graph right now. So my dear, there should be no breaking. This line will be the line, it will be freehand curve right now, freehand curve. So there should be no breaking, it should be a freehand curve. Let's try to get this freehand curve. No, see pending. Freehand curve, my dear friends. Now from here, like this. There should be no breaking, not from one point to the other, then second to third, third to fourth. No, continuous, a freehand curve. When you are drawing this, so you have scored your final mark also. Then use your graph. Now read the question really carefully. Use your graph to determine the value of the object distance u1 when the magnification m is equal to 1. So you have to locate it on the graph. M is equal to 1. Where is m equal to 1? My dear friends, here m is equal to 1. You have to show it to the examiner very clearly. Make use of your scale and do it. So how much is this? See, each line here is, each small scale is equal to point, that is equal to 0.5. So it means this one is 31.0. How it is 0.5 if you ask me? One small scale again, the difference between two consecutively marked values, 25 minus 20 over 10. As you will simplify, answer will be 0.5 centimeter each box on y-axis. So 31. What I'm going to write here, unit is already written. So this is 31.0 centimeters. Now calculate the focal length f of the lens using the equation f is equal to u1 f of the lens using the equation f is equal to u1 over 2 divided by 2. So f is equal to u1, which is 31 in centimeters, divided by 2. So answer will be 15.5, and centimeter is again mentioned. It's not necessary that every time it will be given. So sometime it is available, sometime it's not given. So be careful, check the unit, very final answer. And for such sort of cases, the answer will be within a range. Don't worry that there will be only one answer. So there will be a range of answer. So your answer should be within the range, either even at the extreme point or even at the lowest point, but it should be on the within the given range. No worries at all if it is highest or lowest, but it should be within the range. I think, if I'm not forgetting, the answer for this one is almost from 13.4 to 16.4, something like this. So that is, even if your answer is 13.4, that will be accepted. Even if your answer is 16.4, it will be accepted, or any number in between these two values. Now state 2 precautions that you would take with this experiment in order to obtain accurate readings. And this is just a recall memory, a repeated question. Many answers you can write here. Like, measure all the distances from the center of the lens. Perform this experiment in a dark room, shaded area, because illuminated object is there, then it will be more focused if the experiment is performed in a dark room. Move the screen slowly to get well-defined image. Or you can say, ensure that center of the object, center of the lens, and the center of the screen are at same height from the bench, or they are aligned. And also mark the center of the lens to measure the distances. So many answers are there. I'm going to write first answer like, move the screen slowly get well-defined or focused image. And another one, again formula, you can write that a recall memory perform the experiment in darkroom or shaded area. Both the ways it will be considered correct. Perform the experiment in the darkroom or shaded area is also workable. Now my dear friends, let's move to the next question. This is on electricity, but this is a planning question. We have to plan within the given circumstances. A student investigates the resistance of different wires. Plan an experiment to investigate the resistance of wires made from different metals. Now these different metals, my dear friends, this is independent variable. Very important this to differentiate first in the beginning of this question number 4 always, or this planning question in physics, which one variable or quantity is independent. And the independent quantity is basically the quantity which is changed by the experimenter. Either it is student who is performing the experiment, or the teacher or supervisor or lab attendant who is supervising or performing the experiment in front of the students. He will be changing some variable, like in this experiment, resistance made from different metals. So it is the teacher or the student who will choose one metal and connect it into the circuit, then proceed the experiment, find the resistance. Then he will replace that metal with another metal and in this way he will keep on changing the metals into the circuit and then getting the resistances. So types of metal here, they are the independent variables or quantities. More suitable, you should go with variable. Whereas the resistance of the wire, this is a dependent variable. So if the metal will be changed, even for the same dimension, the resistance of the wire for that particular metal, it will be changed. So dependent variable. Resistance is calculated using the equation R is equal to V over I. The following apparatus is available: ammeter to measure the current, voltmeter to measure the potential difference, power supply to power them up, provide them with the EMF, meter rule to measure the lengths of the metal wires, a selection of wires made from different materials. You can also use other apparatus and materials that are usually available in the school laboratory. In your plan, you should know these are the guidelines which we have to follow. Write a list of suitable metals for the wires you will investigate. Draw a diagram of a suitable electrical circuit using standard electrical symbols. Explain briefly how to carry out the investigations. State the key variables to keep constant for a fair test, and then draw a table or tables with column headings to show how to display your readings. You are not required to enter any readings in the table. Please don't. You are not performing the experiment while the exams, so you have to just perform it or explain this plan theoretically, orally, not with some numerical data. So my dear friends, first of all, write a list of suitable metals for the wires you will investigate. So we can take we can start like circuit. First of all, we can say copper, aluminium, and iron are the metals. See, are the metals for wires. Are the metals for the wires to be investigated. Then the next is the circuit diagram. The circuit diagram is as below or as shown below. So there is power supply, so don't use a battery, show power supply. Then better to give a switch. They did not mention. If they mentioned, okay. If they did not mention, even no problem, you should say it. Ammeter to measure the current, and it is always in series. Then give some space here to connect the wire in between. And then, my dear friends, here you can show a voltmeter, and voltmeter is always across the component. And let's start. In the beginning, we can show here a wire. Let there is a copper wire. So show this one, and now label this whole circuit diagram. Better to label it. This one is power supply. This is a switch. This is an ammeter. Here this is a voltmeter, and this one is a metal wire. Even if you want to add on extreme left side here, if there is mentioned about the variable resistor, so then you can connect it over there. Variable resistor is not mentioned, so I'm not using it here. Even if without mention, you can mention here if you want, but you can mention it here because variable resistor, just like ammeter and switch, it is always connected in series in a circuit. Now, my dear friends, after this, they are saying, now explain briefly how to carry out the investigations. Explain briefly how to carry out the investigations. So, my dear friends, we can say, connect the circuit, or when the circuit is connected as shown, then we can turn on the current, and now you can say or start writing the answer, that set up the circuit as shown above. And then what to do? Measure a fixed length of wire, fixed length of wire and connect it in the circuit. close the switch. Mean turn on the current. Close switch mean turn on the current. Close the switch and measure current through the wire and voltage, or better to say potential difference, both the ways it's okay, across the wire. Current is always through and potential difference voltage across the wire. Which wire? Like we have connected the copper wire in the beginning. When it is done, then across the wire, then resistance is found by V over I. Now dear friends, know the purpose of or importance of this independent variable. Independent variable is the different types of metal. Now you have to repeat the experiment. Repeat the experiment by connecting different metal wires. So whatever the independent variable will be there, so we will change that independent variable to get more set of data in the experiment. So that's what I'm going to write right now. So repeat the experiment by connecting different metal wires in the circuit. Whatever the experiment is, you have to write this, repeat the experiment by, now in this case, by connecting different metal wires in the circuit. And any other experiment, whatever the independent variable, we will be changing the independent variable to collect more set of data. So that is very important. Then what is next? Next is state the key variables to keep constant. So key variables to be kept constant are, now this you have to write in the form of paragraph. Recommended length and diameter, better to say length and diameter, or area of cross section, anyway it's okay. Length and diameter of each metal wire is kept constant for a fair test. Right now we are checking or investigating the effect of type of material, in other words the metal, on the resistance of wire. If we will change the length every time or diameter every time, so then resistance is also affected by the length and diameter of the wire. So we will keep them constant. Right now our investigation is how the resistance is affected by the type of metal. Then next, in the end, I think he will be asking now for the draw a table. Again, when you have to draw the table, my dear friends, when you are going to draw the table, remember it that you are starting with the independent variable, which is type of metal wire in the first column. Then of course you can write, you are measuring voltage in volts, then current in amperes, and then in the end resistance in ohms. Now see, dependent and independent variable are also workable here. What do I mean by that? See, the independent variable is always in the table of the data, always on the extreme left, first column. And the dependent variable, which is a resistance in this case, that is always in the last column. And no, resistance is not directly found here. We did not use the ohm meter, we have used voltmeter and current, so we can put them both before resistance in different columns. Now whatever they ask we have done, but one extra point for safety measures you can write. And what should we write here? We can say use low currents in the experiment to reduce what? Reduce heating effect of current. Heating effects of current, because within our syllabus and in journal, current has three effects. Heating effect of current, like electric kettle, iron, and even the cables, when they are carrying current for a long time, they are getting hot. So heating effect of current and magnetic effect of current are with us in the syllabus, and the chemical effect of current, like the electrolysis, that is not with us in the syllabus. My dear friends, this is about the question on planning from this paper. If you have any query, feel free, you can write in the comment section on the channel, and I will try my best to answer those questions as soon as possible. If you feel these explanations useful for you, do subscribe my channel and share with your family and friends. Take care. Bye.